What I'm going to do is demonstrate for you the absorption of a liquid in terms of wavelength. And we're going to use a device that allows us to look at the absorptivity of a material. And we're going to use a spectrum analysis. What I've done is I've prepared 3 crevettes with various dyes. It's just plain old food coloring. Put 1 drop in each cuvette. And here we have red, and we have blue, and we have yellow. So we arranged them this way. We've got the ends of the spectrum and the center of the spectrum covered. So the idea is to analyze one of these fluids at a time as to what you would predict would happen in terms of the transmissivity. We're going to look at how much light gets transmitted, but the graph is actually going to show where the light was absorbed by the liquid. So when we apply this to the ocean, and some of you are using the color of the ocean as a misconception, and a couple of you actually, one of you at least, said something about mixing the colors, and what does that really mean in terms of how does a liquid do it? So we're going to just stick to the basics right now. And what I'm going to do is we'll start with the red. These are very long wavelengths. And I'll just put that into the device. And let me call your attention to the graph that's displayed on the computer. And what you're seeing is a straight line at 0, indicating nothing's going on right now. But what I'll do is I'll activate the collect button, and we'll now collect data. And so we're now collecting data, and here we go. We've got our data. So from this graph, and again you had to graph this week, from this graph you can easily see that what we have is a graph that indicates the blue pretty much got absorbed. And then as we move into longer wavelengths, there's a sort of a plateau in the yellow region, and then a precipitous drop in absorption, which then allows the light to be transmitted 100% in the red. And if we look at this color and put it up against here, we'll look at that, and you see the blue is pretty much wiped out. And yellow is starting to come back. When we get into the red, you're seeing the color that you would expect. So with that in mind, let's try the opposite end of the spectrum. We're going to take the blue. So we'll take blue, place it in its proper place, and we'll then have the computer collect data. Now let's see what happens there. Whoa. And you probably expected the blue to be passed through, which you see, and then as we move to the longer wavelengths, we have a huge amount of absorption. But a very interesting thing starts to happen. As we move to the longer wavelengths, look at this. The absorption decreases and transmission resumes once again. Well, isn't that interesting? All right, one more color, yellow, and we're ready to take on yellow. And there we go. I think you expected this. So the yellow absorbed the blue, as you would expect, and now we move toward the yellow, and look, it lets not only yellow but red through as well.